एवरीवन, कैसे हो सभी लोग? आई होप सब अच्छे होंगे। सो आई एम बैक अगेन विद लेक्चर 7 ऑन बाइनोमियल थ्योरम। अभी आपको पता होगा कि लास्ट तक हमने ऑलरेडी बाइनोमियल थ्योरम में काफी कुछ चीजें कवर कर चुके हैं। ठीक है, जैसे द समेशन ऑफ द बाइनोमियल कोफिशिएंट एज वेल एज सम ऑफ द प्रोडक्ट ऑफ बाइनोमियल कोफिशिएंट एज वेल एज वी स्टार्टेड द बाइनोमियल फॉर एनी गिवन इंडेक्स। ठीक है, तो आज का लेक्चर उसी का कंटिन्यूएशन होगा। अब अगर आपने अभी तक प्रीवियस लेक्चर्स अभी देखे नहीं होंगे, देन गो टू द डिस्क्रिप्शन बॉक्स। ठीक है, या फिर यू कैन क्लिक ऑन द आई बटन ओवर देयर टू एक्सेस द लाइक अ प्लेलिस्ट ऑफ द बाइनोमियल थ्योरम। ठीक है, बाइनोमियल थ्योरम का प्लेलिस्ट आपको मिल जाएगा। स्टार्टिंग से लेक्चर देखना स्टार्ट करो, तभी आपको अंडरस्टैंडिंग समझ में आने वाला होगा। ठीक है, तो शुरू करते हैं आज का लेक्चर। आज का लेक्चर वही रिमेनिंग टॉपिक्स के ऊपर होगा, जैसे मल्टीनोमियल थ्योरम के हम लोग स्टार्ट करेंगे, और कुछ इंपॉर्टेंट और जनरल थ्योरीज भी है जो मुझे बताना था, उसी को लेके हम लोग स्टार्ट करेंगे। एंड इन द कमिंग लेक्चर वी विल starting with the problem solving on JEE Mains and JEE Advanced previous year question. ठीक है, so stay tuned for that. And if you are someone who is new to this particular channel, then do subscribe to this channel. ओके, शुरू करते हैं। तो आज का गोल कुछ ऐसा होने वाला है कि वी विल स्टार्टिंग बाइनोमियल थ्योरम फॉर एनी इंडेक्स, उसके ऊपर क्वेश्चंस बनाएंगे, एज वेल एज वी स्टार्ट द न्यू टॉपिक ऑफ मल्टीनोमियल थ्योरम। ठीक है, नया टॉपिक है मल्टीनोमियल थ्योरम एंड हाउ क्वेश्चंस आर कमिंग इन जेईई मेंस। ठीक है, मल्टीनोमियल थ्योरम पे क्वेश्चंस जेईई मेंस में पूछा गया है, जेईई एडवांस में उतना ज्यादा क्वेश्चन पूछा नहीं गया है। ठीक है, जेईई एडवांस में क्वेश्चंस, जेईई एडवांस के लिए okay, there will be more questions from series of binomial coefficient. Okay, series of binomial coefficient. ठीक है, जेई मेंस में रैंडमली काफी कोई भी टॉपिक से क्वेश्चन आ सकता है। ठीक है, सो इट इज बेटर इफ यू आर प्रिपेयरिंग फॉर जेई मेंस, इट इज बेटर टू प्रिपेयर ऑल द टॉपिक्स। ठीक है, और अगर एडवांस के लिए हो तो देन यू कैन बेसिकली फोकस ऑन दैट दिस पर्टिकुलर पार्ट आल्सो ऑन नाइसली। ओके, क्योंकि इस पार्ट से काफी अच्छा अच्छा क्वेश्चन बनाया जाता है। ठीक है, तो शुरू करते हैं आज का लेक्चर। सो वी स्टार्ट अवर टुडेस डिस्कशन विद अ स्मॉल रिकैप. Okay, so up till now we studied a lot of things about the binomial expansion. So the binomial expansion we studied, that is 1 plus x raised to the power n. Now whenever this n is a whole number, when n is a whole number, okay, if we are writing n is a whole number, okay, so this binomial expansion for n given as a whole number can be written as summation of r is equal to 0 up to n. So there will be n plus 1 terms in it, that is ncr 1 raised to the power n minus r and x raised to the power r. ठीक है, और इसी चीज में अगर ऐसा एक्सपेंशन दे रखा है, जैसे what the first term is 1 and the second term is a variable term 1 plus x की power n, and in this particular term if you have to find the coefficient of x की raised to the power r, then it will simply become ncr. ठीक है, तो the coefficient of x raised to the power r will become ncr. ठीक है, so ये सिंपल चीजें हम लोग ऑलरेडी कवर कर चुके थे। और in continuation with that, in the topic of starting the series, we basically talked about three methods. First is the general method, second is the differentiation approach, and third is the integration approach. तो कहीं भी क्वेश्चंस में अगर दिखता है कोफिशिएंट के साथ, for example there is a variable term multiplied with the binomial coefficient, then you basically approach this particular problem statement by the help of differentiation. और अगर हमें दिखता है कि binomial coefficient के साथ अगर in the denominator there is some variable term, okay, then we basically approach this particular by using the integration approach, and we already solved these two particular results nicely, that is r belonging to 0 to n. This particular result comes as 2 to the power n plus 1 minus 1 whole divided by n plus 1. And similarly this particular result for r is equal to 1 up to n, so you can also write r from 0 to n, because 0 multiplied with nc0 will again be 0, so doesn't matter also. Okay, so if you write r is 0 to n, this particular product will become n into 2 to the power n minus 1, n into 2 to the power n minus 1. Okay, so you must have remembered these two particular results. Okay, and because I am saying you to remember this particular result, because many in time in questions, if you remember the result, you can directly approach the question instead of deriving the particular result that in at that particular present moment. Okay, so let us start forward, and also we studied about binomial for any given index. Okay, we studied about binomial for any given index. Now the binomial expansion for any given index, for example this is a binomial expansion for n is where this particular n is a rational number. Okay, n is a rational number, so n is a rational number and x be a real number. Okay, so in these types of expansion where x is a real number and given the condition, if n is a rational number and given given the condition that modulus of x is less than 1, the modulus of x is less than 1, this is very important condition. अगर n का वैल्यू नेचुरल रैशनल नंबर है, अगर n का वैल्यू रैशनल नंबर है, for the expansion of 1 plus x की power n, where the first term must be unity, where the first term must be a unity term, 1 plus x की power n, where n is a rational number, then on satisfying this particular condition where the modulus of x is less than 1, then this particular expansion can be expanded as 1 plus n into x divided by 1 factorial plus n into n minus 1 divided by 2 factorial into x square plus n into n minus 1 into n minus 2 whole divided by 3 factorial x raised to the power 3 and so on up to the general term will look like n into n minus 1 continually multiplied with n into n minus r plus 1 whole divided by r factorial x raised to the power r and so on up to infinite term. That means for any binomial expansion whose indices, okay, which is raised to the power, for any binomial expansion which is raised to the power in a negative or a fractional number, negative or any fractional number, then that particular binomial expansion has infinite number of terms. Okay, so this is very important conclusion. Also, and while expanding and while using this particular formula, the first term must be an unity term. The first term of the binomial expansion must be a unity term. I hope this particular result is clear. Okay, so this is a very important result that you must remember. Okay, so n should be a rational number and this particular result must satisfy, that is the modulus of x should be less than or equal less than 1. Okay, I hope this particular result is clear. Okay, this particular result is clear. Now let us move further and let us solve one or two questions. Okay, so this is a question which came up in the JEE Mains previous year paper only. Okay, simple question. So you must have remembered the formula by right now, or if you don't remember, I can show you the approach like how to solve this. Okay, so the summation which is shown in the question, so let us represent the summation as S, and the summation is shown something as NCN divided by n plus 1 plus nc n minus 1 divided by n plus and so on up to 1 by 2 times of nc1 plus nc0 divided by 1. Okay, and this particular summation is equal, it is said in the question, it is equal to 1023 divided by 10. Okay, so this is the result of the summation. So how to solve this particular problem? So if you look at the summation is nothing. So if you look at the general term will look like NCR divided by R plus 1. So whatever present in the lower suffix, okay, lower suffix, it is 1 plus the present in the denominator. Okay, the term which is present in the lower suffix is basically 1 plus the term which is present in the denominator. So you can write the general term like this. Okay, so this is a general term. Okay, so this is a general term, and once you are putting the summation, okay, the sigma sign on it, then this particular summation becomes the summation S, that is R belonging from 0 to n. Okay, so if we look to solve this particular problem, so how will you do? We firstly take the help of this particular expansion, that is 1 plus x to the power n is equal to nc0 plus nc1x plus nc2 x square and so on up to ncn x to the power n. Okay, now, with respect to dx, if we are integrating both sides, so let's just integrate both sides from 0 to 1, we get, okay. So if we are integrating both sides from 0 to 1 with respect to dx, okay, with respect to dx, then we will get this particular result as 1 plus x raised to the power n plus 1 divided by n plus 1, and putting the limit 0 to 1 is equal to nc0 x divided by 1, okay, limit 0 to 1. Similarly, nc1 x square by 2 limit 0 to 1 plus nc2 x cube by 3 putting limit 0 to 1 and so on. So if you put the limits and solve, and if you put the limits and solve, you will see that this particular expansion on the right hand side is basically nothing but the series S. Okay, so the S series is basically equal to, so and on the left hand side if you put the limit, this will become 2 to the power n plus 1 minus 1 whole divided by n plus 1 whole divided by n plus 1. Okay, all right. So from here if you look at this particular problem, okay, so from here if you see the problem, So this particular problem, that the summation s is equal to the power n plus 1 minus 1 divided by n plus 1. So from here, if you compare and if you equal it to 1023 divided by 10, so this is equal to 2 to the power 10 minus 1 divided by 10. So from here this particular result, you can see that the value of n is equal to 9, because n plus 1 is equal to 10, so the value of n is equal to 9. So the correct answer of this particular problem is option number A. Okay, so this is a very simple question which came up in JEE mains paper. Okay, so you can see, like, if you remember the result, you can directly solve it within like 1 or 2 seconds. Okay, so that's how important it is to, like, have those particular things at your memory. All right, so okay, if you are not able to remember that, it's not a big deal. Okay, you can simply take this particular result. Okay, all right, let us move further. So let us move further and study about the second problem. Okay, second problem is another very useful type of problem I felt about. Okay, this is a very like a very useful type of problem, because not every time you will be solving this type of problem, but this is a very tricky problem, not very difficult, not very simple. If you're able to think it, it is better. Okay, so if you can see, it is asked for, the question is asking for the sum of the coefficient of the first 50 terms in the binomial expansion of this particular expansion. So if you look at the expansion, this is basically 1 minus x raised to the power 100. Okay, 1 minus x raised to the power 100. So firstly, the very first question that I will frame to all of you, that how many number of terms will be present in this particular expansion. So you will say me that there are basically 101 terms present. Okay, and the question is asking you for the looking for the first 50 terms. Now for this particular problem, I will make use of one property, that is, and you must be knowing of this particular property, that is, of binomial coefficient, that is NCR is equal to NC n minus R. Okay, so you must be knowing of this particular property. So if you know this particular property, then you can understand, like, how to approach this particular problem. Or you might be knowing in the very basic or the initial lectures of this particular binomial theorem, we studied about this particular property only. Okay, so we all know that so if you expand this particular binomial expansion, you will get the term something like that: 100C0x minus 100C1x plus, okay, not x over here, so this will be 100C1x plus 100C2 x square minus 100C3 x cube, and so on up to minus 1 raised to the power 100, that means 1 only, so it will be plus 1, so it will be plus 100C 100, okay, x raised to the power 100. Okay, so it is asking for the sum of the coefficient of the first 50 terms. So if you look at the first 50 terms, the first 50 terms will look like, so the coefficient of the sum of the first 50 terms is something like 100C0 minus 100C1 plus 100C2, and so on up to, and if you look for the first 50 term, so this will become minus 100C49. Okay, so these are first 50 terms, and the term corresponding after that is 100C50 plus the remaining terms, which is basically 100C51, okay, minus 100C51 plus 100C52, and so on up to 100C100. Okay, now what corresponding property that I am going to use is that, is whenever you look at this particular term, this particular 100C100 is nothing but 100C0, that means this term resembles to this particular term. And similarly, if you go on expanding, you will find that the 100C51 minus 100C51 has resemblance to minus 100C49, has resemblance to minus 100C49. Okay, so you can see that this particular summation and this particular summation only except this particular 100C50 terms, you will see both of this particular sum is basically equal to same thing only. Okay, and you know that if you sum of all the coefficient of this particular by putting x is equal to 0, you will end up getting this particular summation. And if you sum of all the binomial coefficient from 100C0 to 100C100, you will get the summation as equal to 0. How? Now in place of x, if you put, x is equal to 1, you will find the sum of all the coefficient. Okay, you will find the sum of all the coefficient, and the sum of all the coefficient is equal to 0. And for the first 50 term, you can see that this is the first 50 terms. Okay, so if you consider the sum of the first 50 terms lambda, so the rest 51, the after this 100C50, the rest of the terms which are present also sum up, and that is also equal to lambda. also equal to lambda. I hope you are able to understand this, because you can see 100c 100 is equal to 100c 0. Similarly, 100c 59 51 with a minus sign is also equal to minus of 100c 49. Okay, by using simple this particular property, that means you can say that it is nothing that the summation, that is 2 lambda plus 100c 50 is equal to 0. Okay, and from here you can do this particular result as lambda is equal to, that means the sum of the first 50 terms of the binomial expansion of 1 minus x to the power 100 is equal to minus 1 by 2 times of 100c 50. Okay, now let us use another property, that is ncr is equal to n by r multiplied with n minus 1 c r minus 1. Okay, so if you do this particular result, if you apply this particular result, you'll find this as minus 1 by 2 into 100 by 50. Okay, 100 by 50 into 99c 49, and you know 100 by 50 is equal to 2, so that means these 2 and 2 get cancelled, and the answer you get is basically minus of 99c 49. So that is option number C, which is the right answer to this particular problem. So the right answer to this particular problem is option number C. Okay, another very simple problem. I hope you are able to understand this particular problem. All right, so let us move further and let us study the questions we were talking about on binomial for any given index. Okay, so let us talk about binomial for any given index. Okay, so we already studied about binomial for any given index as okay. So for the expansion of 1 plus x to the power n, where n is a rational number. Okay, n is rational number and x is a real number, where modulus of x is less than 1 and the first term of this particular expansion is unity, we know that this particular expansion as the result of this particular expansion as 1 plus 1 plus nx divided by 1 factorial plus n into n minus 1 divided by 2 factorial into x square, and so on up to the in rth term is n minus n into n minus 1 and so on multiplied with n into n minus r plus of 1 whole divided by r factorial whole divided by r factorial x to the power r, and so on up to infinite terms. Okay, and so on up to infinite terms. Okay, so what you can see from here, the general term of this particular expansion, the general term, okay, so the general term is, so you can consider the general term as t r plus 1. Okay, the t r plus 1 term is equal to, okay, that is, this is the t r plus 1 term is equal to n into n minus 1 into n minus 2 and continually multiplied with n minus r plus 1 whole divided by r factorial into x to the power r into x to the power r. This is the general term or the t r plus 1 term. Okay, so what you can see that this is the general term. Okay, and similarly by putting different numbers of n is equal to 1 up to, like, the most general expansion that we will be basically seeing in this particular direction is basically like the I would tell you to have a idea or the glimpse of this particular expansions, that is, if what is the value of 1 plus x to the power minus 1. Okay, it is basically equal to 1 minus x plus x square minus x cube and so on up to infinity. So if you put the geometric expansion, so since the value of a modulus of x is less than or 1, you can apply the concept of summation of geometric progression for infinite terms. Okay, and similarly, the second result, 1 plus x to the power minus 2 is equal to 1 minus 2x plus 3x square minus 4x cube and so on, okay, up to infinity. You can deduce this particular results by putting this particular formulas. Okay, similarly, the third result is basically equal to 1 plus x to the power minus 3 is equal to 1 minus 3x plus 6x square minus 10x cube and so on up to infinite. Okay, so there will be infinite number of terms. And similarly, by putting in place of x by putting minus of x, you get the expansion of 1 minus x to the power minus 1 is equal to 1 plus x square and so on up to infinity. Similarly, 1 minus x minus whole to the power minus 2 is equal to 1 plus 2x plus 3x square and so on up to infinity. Similarly, 1 minus x whole raised to the power minus 3 is equal to 1 plus 3x plus 6x square plus 10x cube and so on up to whether any general term is r into r plus 1, r plus 1 into r plus 2 whole divided by 2 into x raised to the power r and so on up to infinite number of terms. Okay, so the difference between the binomial theorem for positive and exponent and for general exponent is basically clear by this particular result. ठीक है, I hope ये वाला result clear हो चुका होगा. ठीक है, now let us solve some problems, okay, regarding this. So let us take a very small example. Okay, the first example that I am taking is, now for it is given in the question that the modulus of x is less than 1, then the coefficient of x to the power n in the expansion of in the expansion of 1 plus x square and so on up to infinite. Okay, now why these particular results are very important, whole square is, okay, so it is asking in the question. Now before starting a wala topic, okay, I wanted to make you very clear that why these particular results are very important. Now up in the coming topics or the lecture topics, that is permutation and combination, where you will be starting about the methods of like multinomial concepts, okay, or you so on called the beggars method, or a very important method, or the beggars method. So there you will learn a very important approach, that is the multinomial approach of solving the general solving of any general equations, okay, or example like a general linear equation will be given in terms of x, y and z, and you will basically need to find out that what is the number of solution that can be possible on given condition that x ranges from this particular value, y also ranges to particular value, and z also ranging to a particular value. So those questions, this particular result will be very important. Okay, so I hope you must remember this particular results. Okay, so the question is talking about you have to find the coefficient of x raised to the power n in the expansion of this particular result. So if you look at this particular expansion, that is 1 plus x square and so on up to infinite whole raised to the whole square is nothing but equal to, if you see and look at this particular result, this is equal to 1 minus x raised to the power minus 1 whole raised to the power square. Okay, and this will make it 1 minus x the whole raised to the power minus 2. Okay, so it will make it 1 minus x whole raised to the power minus 2. So if you look at this particular 1 minus x whole raised to the power minus 2, the expansion is 1 plus 2x plus 3x square. But if you're not knowing about anything, you can directly write the general term, that is the tr plus 1 term is equal to, so this is equal to n into n minus 1. So in place of n, you will put minus 2. Okay, so in place of n you will put minus 2. Okay, and n minus 1, so this will become also, yeah, this particular term will become, so from here this is minus 2. Okay, so if you look at this particular general term, okay, so if you look at the general term, the general term looks like this particular n into n minus 1 into n minus 2 and so on, it goes on up to n minus r plus 1. So if you look at this particular expansion, this will become minus 2 into minus 2 minus 1, that is minus of 3, and so on up to minus 2 plus r minus r plus 1. Okay, so this will go on up to minus r plus 1 and whole divided by r factorial, okay, into x raised to the power r. Now since you are looking for the x raised to the power n, so that means r value should be equal to n. So from here the coefficient of this particular expansion will be nothing, but you can remember the result also, it is basically equal to, n plus r minus 1 cr. Okay, so you can remember the coefficient of x raised to the power r. So you can remember the coefficient of x raised to the power r from the expansion of 1 minus x raised to the power minus of r, okay, is equal to n plus r minus 1 cr. Okay, so this particular result will give you the answer, that is basically equal to, so the coefficient is equal to, so the coefficient is equal to in the, so coefficient in 1 minus x raised to the power minus 2 is basically equal to, is n plus, so in place of r you put 2 minus 1 c r minus 1. Okay, c r minus 1, I'm sorry, c r minus 1. Okay, so this will c r minus 1, that is again 1, and this particular value will give you the result that is n plus 1. This will be giving you the result that is n plus 1. So you can remember this particular result as a note, okay, and as a very, very important note, okay. Now, why I'm saying is very important because in the question of permutation and combination, you will know the importance of this particular result, okay. The importance of this particular result will be lying more in the chapter of permutation and combination, okay, rather in this particular chapter. Okay, so you must remember this particular important reductions, okay. That is the reduction for general coefficient in the expansion of 1 minus x raised to the power minus r or 1 plus x raised to the power minus r, okay. So the result is the coefficient of x raised to the power x raised to the power sorry x raised to the power n, better to write like this, x raised to the power n in the expansion, because we know that in the expansion of whenever the expansion includes a negative term, there will be infinite number of terms. So 1 minus x to the power r, this particular result is equal to n plus r minus 1 c r minus 1. So in place in this r, the only the value of r will you put, okay. So you put only the value of r. So the coefficient of x to the power n in the expansion of 1 minus x to the power minus r is basically n plus r minus 1 c r minus 1. Okay, so you must remember this particular result. And this is a very, very important note. I am again telling this is very important because in the chapter of permutation and combination, we will use this particular result. Okay, now let us solve again another important example then. Okay, let us talk about another example. So this particular example, again it is saying that in the expansion of 1 minus 2x whole raised to the power 3 by 4, what is the general term in it? Okay, what is the general term? So it is looking for the general term. Now before finding the general term, what thing you need to basically try out is that for this expansion, it is given a raised to the power fractional part. So when it is a fractional part, you have to check whether the modulus of this particular thing is less than or equal less than 1. So, and the first term should be unity, okay, and the first term should be unity. So we must mention in the question that 2x mod is basically less than 1. Okay, so this particular condition holds true, then only you can be able to solve this particular problem. So if you look at the general term, that is the tr plus 1 term, you will find this particular term as, so I am doing the solution only. Okay, so general term or the r plus 1 term will basically equal to n into n minus 1. That means become 3 by 4 into 3 by 4 minus 1 into 3 by 4 minus 2 and so on up to 3 by 4 minus r plus 1. Okay, whole divided by r factorial whole divided by r factorial into minus 2x whole raised to the power r minus 2x whole raised to the power r. So if you expand this particular relation, so if you expand this particular relation, you'll get the value as, so if you expand this particular relation, you'll get the value as 3 by 4 multiplied with minus of 1 by 4 multiplied with minus of 5 by 4 and so on up to 7 minus 4r by 9, okay, by 4, sorry, 7 minus 4r by 4 whole divided by r factorial into minus 2 to the power r into x to the power r. Okay, and if you again expand this particular, you will find it as 3 into minus 1 into 5 and you go on up to 4r minus 7. Okay, 4r minus 7 with a minus preceding to it. So the whole divided by, so there will be 4 times of how many times of r is 4 is present in multiplication, it is basically r times the 4 is present, so 4 to the power r into r factorial, okay, into minus 1 raised to the power r 2 to the power r x to the power r, and this will be, if you expand this particular will become minus of, so you will find it rather that is minus 1 is present over here, minus 1 is present over here, and minus 1 is present again, so this will be minus 1 to the power r and again minus 1 to the power r, so this will club up and you will find that there will be resulting in a minus sign over here. Okay, so there are r minus 1 is present and this is r times minus 1 is present over here, so minus 1 raised to the power 2 r minus 1, that will be an odd number, that means a negative will be there in the product, so this will be 3 into 5 into 3 into 5 into, sorry, or better to write 1 into 3 into 5 into, and so on up to the general term will look like 4r minus 7 whole divided by, whole divided by, whole divided by, if you cancel this 2 to the power r with 2 to the power 2r, this will again become 2 to the power r. So this value will become, so from here this value will become 2 to the power r, 2 to the power r factorial into x to the power r. So this is the general term of the particular expansion of, in the expansion of 1 minus 2x whole raised to the power 3 by 4, whole raised to the power 3 by 4. So this is the general term of this particular expansion. I hope this particular result is very clear. All right. So let us move further. Okay. So let us move further and study another important example. Okay. Now this is another very important example. Again, a simple or very simple example you can talk about. Okay. So let me take that example. So this is the third example. So the example says something like that. You have to find the coefficient of x raised to the power n in the expansion of 1 plus x divided by 1 minus x whole raised to the power 2, whole raised to the power 2. So you have to find the coefficient of x to the power n in the expansion of 1 plus x divided by 1 minus x whole raised to the power 2. So if you look at this particular expansion, this is nothing but 1 plus x whole square multiplied with 1 minus x raised to the power minus 2, raised to the power minus 2. So you know that the expansion of this particular term is basically finite, and this will become 1 plus 2x plus x square whole multiplied with, and this particular expansion is equal to 1 plus x square and so on up to infinity. Okay, and since you have to look for the coefficient of x to the power n, you can do this in the fashion that if you take n minus 2 from here and take x square from here, if you take x from here, then x minus 1 from here, and if you take x to the power n from here, then this will become 1 from here. Okay, so the coefficient of, so the coefficient of x to the power n is, so the coefficient of x to the power n is, and this is the basic solution only. Okay, so the coefficient of x to the power n is equal to, so if you take 1 from here, so if you take 1 from here, 1 multiplied with, from here you have to take the coefficient of n, that means that will become n plus r. What is the value of r? R is basically 2. So n plus 2 minus 1, c, r minus 1, that is 1, plus if you take 2x from here, if you take 2x from here, then you have to take n minus 1 from here, that will become 2 into n minus 1 plus r minus 1 c r minus 1 plus, okay, c1, plus if you take x square from here, you take n minus 2 from here, and that will become 1 into n minus 2 plus 2 minus 1 c1, and this is the value of the coefficient, and the value will come out, if you evaluate this value will become n plus 1 plus 2 times of, if you solve this will be equal to n plus, if you solve this particular will become n minus 1. Okay, so the value of the coefficient is equal to, so minus 1 and plus 1 got cancelled, and the value will be equal to 4n, and the value will be equal to 4n. Okay, and the value will be equal to 4n. So the coefficient of x raised to the power n in the expansion of this particular, in the expansion of 1 plus x divided by 1 minus x whole raised to the square is basically equal to 4n, is equal to 4n. I hope this particular result is clear. So you can understand how important this particular note is. Okay, so this is a very important note, that is the coefficient of x to the power n in the expansion of 1 minus x to the power minus r is equal to n plus r minus 1 c r minus 1. You must remember this result. Okay, so as far it is very good. So let us move further, and let us we will solve questions also. Okay, so let us try to understand, let us study what is meant by the multinomial theorem. Okay, so what is meant by the multinomial theorem? Okay, multinomial theorem. Okay, so what is meant by the multinomial theorem? So as of now, we studied only for binomial theorem. And what is meant by the word binomial? That means whenever there will be two terms present in the, two independent terms present in the expansion, then this particular expansion was known as binomial expansion. And in similar approach, if we look about, if the number of independent terms in the expansion is basically more than 2, then that particular expansion is said to be multinomial expansion. So before starting multinomial expansion, let us try it and study from the very basic. That is that what we studied in the binomial expansion. For example, x plus a whole raised to the power n, where n is a positive integer, or you called it as a whole number. So from binomial expansion, we know this particular expansion can be written as r belonging to 0 up to n, ncr. Okay, x raised to the power n minus r, a raised to the power r. Okay, where n is basically a natural number, to be very specific. Okay. So this is our binomial expansion we studied about. And what we know about NCR, we can write this NCR as, so if we r is value NCR can written as n factorial whole divided by n minus r factorial into r factorial in the denominator, x raised to the power n minus r, a raised to the power r. Now what you can talk about this particular coefficient. So if you look at this is n minus r, and if you add with r, you will get the value as n. So if you call this particular value as a factorial and this value as b factorial, you can write this as x to the power a and a to the power b. So this a is not very the same as this a. So you write it as a dash factorial and b dash factorial. So this will be x to the power a dash and a to the power b dash. Okay. So what you can do like this, you can also write this expansion as, you can also write the expansion as sigma, where r plus, so instead of a dash and b dash, if you take this as, if you take the term, this particular term as r and s. Okay, instead of writing n minus r factorial, you would call this as r and r as value as s. So you can write this as r plus n, s is equal to n. Then you can write this expansion as n factorial divided by r factorial divided by s factorial whole raised to the power into x raised to the power r and a raised to the power s. Okay, so you can write this particular expansion like this. Okay, where this condition must satisfy, that is s plus r is equal to n. Okay, now, on considering this particular idea, now this particular result, this result can be generalized as, and this result can also be generalized as for when there are more than one terms, or when there are more than two terms present in the expansion, that is expansion as x1 plus x2 plus x3 plus x4 and so on up to x k whole raised to the power n. This particular expansion can be written as sigma, where, now let us consider some number r1 plus r2, and where r in rk is equal to n, you can write this particular as sigma of this particular number n factorial whole divided by r1 factorial divided by r2 factorial and so on up to rk factorial into x1 raised to the power r1, x2 raised to the power r2 and so on up to xk raised to the power rk. Okay, xk raised to the power rk. So you can write this particular generalized this particular approach in this particular fashion. I hope this particular result is clear. Okay, so you can generalize this particular result of binomial to multinomial, from binomial to multinomial. I hope this particular result is clear. Now let me write this result again. So you can see from here the general term of this particular expansion as, okay, the general term of this expansion of this expansion is equal to n factorial divided by r1 factorial into r2 factorial into r3 factorial and so on up to rk factorial. Okay, and then multiplied with x1 raised to the power r1 into x2 raised to the power r2 and so on up to xk raised to the power rk. Okay, so this is the general term of this particular expansion. So if you consider the general term as t r plus 1 term, or you consider it rather to say it better as, because we don't know about how many terms will be present. It will depend upon the number of expansion term which is present in the expansion bracket. Okay, that is what is the value of k. What is the value of k over here? This will basically decide like how many number of terms will be present. Now this particular question can also be solved as, okay, so this is a particular problem also. So if you look at what is the number of terms which will present in this particular expansion, you can you can talk about it like this. Okay, you can talk like this. So I can write this as a note. Also you will learn the derivation of this particular result in permutation and combination. Okay, you will learn the derivation of this particular result in permutation and combination rather. So what you can say, the number of terms present in this expansion, okay, in this expansion is the number of terms present in this expansion is equal to, is directly, you can remember this result as n plus k minus 1 c k minus 1. Okay, so the number of terms which is present in this particular expansion is equal to n plus k minus 1 c k minus 1. Now how this particular result comes true, you can take an idea also. If you want to know how this particular result comes to, this particular result is nothing but the coming from the result of binomial permutation and combination by solving, because in order for this particular condition, or in order for this particular result to be true, the condition that must be true is basically r1 plus r2 and so on up to rk is should be equal to the summation of this particular variable number. The summation of this particular variable number must be equal to n. And if you know about the linear equation solving, or number of solution for this particular equation from the result of binomial theorem, from the result of permutation and combination, you will say that this particular result is nothing but equal to n plus k minus 1 c k minus 1. Now how to solve this particular approach, you will learn in PNC. Okay, you will learn in PNC by ball stick method. Okay, or many people call it as ball and stick method, or many people call it as beggar's method. Okay, beggar's method. Okay, so you will learn in this particular methods. Okay, in this particular method of permutation and combination, you will learn these particular methods. Okay, when I will be teaching about permutation and combination, so let us write this at will be taught in permutation combination. Okay, so you will, for the time being, you can remember the result as n plus k minus 1 c k minus 1. Okay, I hope this particular result is clear. All right, so let us move further and let us try to solve one example problem relating to it. Okay, so the very first example, now you can find many questions will be coming out for by this multinomial theorem. You can find many problems in JEE Mains. Okay, so let us solve one problem. The problem says that in the expansion of, let us take a very simple problem. Okay, in the expansion of 2x plus y plus 3z whole raised to the power 10, what is the coefficient of x raised to the power 2, y raised to the power 5 and z raised to the power 3. So if you sum up all these powers, you will find it is equal to 10. That means you can solve this by multinomial theorem. So for this particular multinomial expansion, so if you do the solution of this, okay, so if you solve this particular problem, so if you do the solution of this, you can write the general expression as something as sigma, where, and if you take r1, r2 and r3 as a variable power and is equal, should be equal to 10, as equal to 2 to the power x raised to the power r1, okay, y raised to the power r2 and 3z raised to the power r3 multiplied with 10 factorial divided by r1 factorial into r2 factorial into r3 factorial. Now we have to look for coefficient of x square y raised to the power 5 and z raised to the power 3. That means r1 is equal to 2, r2 is equal to 5 and r3 is equal to 3. So if you put this, then you will get the coefficient value as, then you will get the value of coefficient as 2 to the power 2, okay, and 3 to the power 3 into 10 factorial divided by 2 factorial 5 factorial into 3 factorial. So this is the result of this particular expansion. Okay, so this is the result of this particular expansion. So the coefficient of this particular x square y to the power 5 z cube in this particular expansion is equal to this value. All right, so this is a very pretty simple question. Okay, now let us take out our question which can come up in your examination. So this was a question also from JEE Mains paper only. Let me take that particular problem. So the problem says that you have to consider, okay, you have to consider for the coefficient of um, you have to consider for the coefficient of x to the power 5 in the expansion of, you have to look for the coefficient of x to the power 5 in the expansion of 2 minus x plus 3x square whole raised to the power 6. Okay, now this particular problem can also be approached by the using the concept of binomial, by considering this particular as a one fixed quantity and this is a second quantity. But if we want to use the concept of multinomial, because this question came up in JEE Mains, okay, and it is asking you to use the concept of multinomial only, so you can write a general expansion. Okay, I'm solving it. Okay, so the solution will look like, so if you look at the expansion of this particular result, the general term you can write it as, so the general term, you can write like this. It is, the general term will be 6 factorial divided by r1 factorial into r2 factorial into r3 factorial. Okay, whole multiplied with 2 to the power r1 into minus x to the power r2 into 3x square whole to the power r3. Okay, now you have to look for the coefficient of x bar 5. Okay, so you have to look for target for the x bar 5. That means x bar 5 will become when r1, sorry, when r2 plus 2r3 is equal to 5, okay, that will become r2 plus r3 is equal to 5, and we know one important result, that is r1 plus r2 plus r3 should be equal to 6. So these two solution must simultaneously hold. Okay, these two solution must simultaneously hold. Now for solving this, we have to go on putting values of r1, r2 and r3 and check for it. So if you put r1 is equal to 0, r2 is equal to, so if you put r1 is equal to 0 and r2 is equal to 1, then you will get r3 is equal to, so if you put r1 r2 is equal to 1, then r3 will become equal to, it will become equal to 2. Okay, then r2, sorry, so if you look at r3, this will become 2 only, and r1 is equal to 1, so 1 plus 4, yeah, it is possible. Similarly, if r1 is equal to 0 and r2 is equal to 3, r2 is 3, then r3 is equal to 1 is also a possible solution. Okay, similarly, there will be another result. When, now let us put r1 is equal to 1. So if r1 is equal to 1, okay, no, this particular solution won't hold. This particular solution won't hold because r1 plus r2 plus r3 should be equal to 6. Okay, I'm very sorry. So this particular result won't hold. Okay, okay. So if you put r2 is equal to, so again if you put r2 is equal to 0 and r3 is equal to, and so if you put, sorry, r3 is equal to 0, let us put r3 is equal to 0 and check. Okay, so this is basically you have to do by hit and trial only. So if you put r3 is equal to 0 and r2 is equal to 5 and r1 is equal to 1 and r1 is equal to 1, then this particular solution can hold true. Okay, and similarly, if you put r2 is equal to 2, okay, r1 is equal to 2. Okay, so if you put r1 is equal to 2 and r2 is equal to, so if you put r2 is equal to 3 and if you put r3 is equal to 1, yes, this particular condition will also hold true. So if you put r1 is equal to 2, r3 is equal to 3 and r2 is equal to 3 and r3 is equal to 1, this particular both the equation will hold true. And simultaneously, if you put r1 is equal to 3 and r2 is equal to, if you put r2 is equal to 1 and r3 is equal to 3. Okay, sorry, why to put 3 again, as 2 only. Okay, so if we put r3 is equal to 2, then also this particular relation will hold true. Okay, so you can see that r3 is equal to 2 plus r2 is equal to 5, as well as r1 plus r2 plus r3 is equal to 6. So this condition hold true. That means there are basically three possible terms. Having x to the power 5 in the x to the power 5 as the expansion terms. Okay, in the expansion term, that means if you put this particular result of r1, this particular set of value, you will get the first coefficient. If you put this set of value, then you will get the second coefficient of x to the power 5, and if you put this particular value of r1, r2 and r3, you will get the third value of the coefficient of x to the power 5, and that's how you basically and add them and you get to the result of the coefficient of x to the power 5 in the expansion. Okay, so you must be able to solve this on your own. So just the value is like putting the values and just checking out for the answer. So I hope you can do this particular on your own. All right, so it was whatever we need to cover from the multinomial theorem. Okay, so there will be one more lecture considering the binomial theorem, where we will basically cover the remaining topics. Okay, where we will basically covering the remaining topics of binomial theorem, and also I will take up some few important problems also, which came up in a JEE advanced paper. Okay, so that is it for today's important lecture. Okay, I hope you are liking this particular video. If you did like this particular video, don't forget to like as well as subscribe to my channel. All right, so I'm taking a leave from today's lecture, and that's it. Thank you.